Yes, welcome back guys to Deeper into Maths, and today we'll be learning about an interesting chapter, circles, which is of geometry. So please stick with us. So now let us start by actually drawing a circle on the coordinate axis as we move on. And this is a circle, this is x-axis and this is the y-axis in its usual form. And let this be the center of the circle. Let it be h comma k, and let this be the radius r. So the general equation we can in center radius form is x minus h the square plus y minus k the square equals to r square. It has a very simple derivation which can be done easily by plotting on the distance formula, and then you can get it. So we won't be going into that. And now let us understand another form of writing circle, and the second form is diameter form, and it can also be proved easily. So please check up the derivations of both of these forms and also the general form of a circle, which I will introduce to you in the next minute or so in the board textbooks or even in NCERT. So the diameter form is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So this is form. So now let us move further and now go into the general equation. This is quite important if we want to know what it is. Mostly the circles or any geometrical equation would be mentioned in this form, so it is quite important to know this form very well. So the general equation of a circle in its general form is x square plus y square plus 2gx plus 2fy plus c equal to 0. Wait a minute, we have seen this kind of equation. Now let me generalize it a bit. Now we have seen it somewhere. So how has it been derived? So we'll go into that now and understand. So in locus we understood the general equation of a curve is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. So now what has the change happened? The change has happened in this part. If we see, let me replace some colors. Yes. The change has happened in this part. The hxy term is 0 and a is equal to b. So now we'll be writing after this the general conditions, and from this we have derived the general form, that is x square plus y square. I'll write it a bit general, ax square plus ay square plus 2gx plus 2fy plus c equal to 0. And now let me put it in the important, as this is also quite important in terms. So now, after knowing this general form, let us now understand the conditions for a circle, because there are various other things included in the conics section of geometry, that is parabola, hyperbola, ellipse and circle. So what distinguishes all of this? Let us know that, and then we'll go on and write what a circle has. So let us remove this, as this both is just the same, so you understand it, because this is the general form written in the textbooks, in all the theoretical textbooks. So now let us understand the conditions for a circle. So the basic mathematical conditions, not the geometrical ones, the ones that we see on graph, we won't be discussing about it. We would be seeing the conditions that can be applied over here as mathematically as we see in those equations. So the first essential condition is delta must not be equal to 0, where the delta is the determinant of AHG, HBF, GFC. We have to learn this delta value, as it would be very much essential. This should not be equal to 0, and this is seen in two cases now. One, in case of pair of straight line, it is equal to 0 in pair of straight line, the delta. This is not equal to 0 for the conic section. And if it is equal to 0, then it is either a pair of straight line or equations of two lines combined. And this becomes the first condition. So now let us understand the second condition. The second condition is that the h must be equal to 0 in the equation this. So h is equal to 0, and the third equation that we saw over here only, that a and b are equal, so we eliminated those, and hence we write a equal to b in general equation of a curve. I'll write it here, underline it. Yes. So now these three conditions are met often times, but sometimes there are cases where the given equation is not a circle and it doesn't exist. Sometimes it just shows us it is a point. So how do we identify it? So we identify it by adding the fourth condition, that is radius must exist. So now you might be asking, how do we find out the radius from this equation? So in this equation, the center coordinates are minus g comma minus f, and radius is equal to under root of g square plus f square minus c square. So this is there and this is also there. Let me box these both as they are important of from other pen. So okay, now that we have understood these two things which are very much important, these two things we would need all the time. So now that we have discussed the conditions for being a circle and we have established the circle, so let us discuss some cases that are derived from this general case. This general case. Oh, this general case of general equation. So now let us understand general equations when circle is A on x-axis. So now when the circle is on the x-axis, the y coordinate is equal to 0, and then let us make the y coordinate 0, so this term would get eliminated, this term, then this term would also get eliminated. So let us not write those terms. Okay, so now let us write our equation x square plus 2, oh the y square term is there, sorry, the center would have minus f as 0, so the f1, this thing, becomes 0. So I'm sorry for that. So x square plus y square plus 2gx plus c equal to 0. So now here the radius, oh sorry, we can say the radius to here. First let us talk about the center. The center is minus g comma 0 and radius is equal to root of g square minus c. Let us discuss the second case on y-axis. So the equation becomes x square plus y square plus, now let us see, the gx term would be 0 as on the y-axis. This indicates that the x coordinate of center is 0, is equal to 0. So this term minus g will be 0 now, so this term would get eliminated, and hence the resultant equation would look something like 2fy plus c equal to 0. So now repeat with me, the center would be 0 comma minus f and the radius will be equal to f square minus c. Now let us take the third case touching x-axis. At such case, we have a written theory that c becomes equal to g square. Touching the x-axis means that the graph would look something like this. I'll draw the graph, just a minute. This is x-axis, this is y-axis, and let us draw our circle. I'll draw a random circle first, then I'll rearrange it. Yes, so now I shall rearrange it. This circle just touches, now this is a circle that just touches the x-axis. Let the center be h comma k, and I'll write here just touch x-axis. At such time the condition would be c equal to g square. So now let us discuss the D one, that is touching y-axis. At such time the c would be equal to f square. These are easy conditions to remember, not a lot, because this is just the initial part of the conic section. And now let us draw the graph for how it looks. This So this is the x-axis, this is the y-axis, and oh sorry, it became an ellipse. I can't. So now this equation is just touching the y-axis. Let us draw it. Now it's correct. I'll write it like this. I'll indicate it. Just touching the x-axis, just touching the y-axis. So now let us discuss another condition when it touches both axes. In such case, the C would be equal to G square plus F square. Yes. This too we shall remember. And now I shall show you this graph too. It is quite easy and you might have even visualized it. It's not that difficult. And this circle is touching both the axes just like this. I'm indicating it with this arrow. Let this center be h comma k. Let this with origin. And now let us discuss the last case of this thing. The EF that is passing through origin, and at such time the C would be equal to 0. This is also pretty obvious, as if we put the value of G and F as 0, 0, then the C becomes 0 over there. And no need for drawing the graph for this, as it is obvious, you know. And now let us understand some bit of a theory of the intercepts made. Intercept made by circle number 1 on x-axis. On x-axis, this is given, this has a ready formula again, which we have to remember, 2 under root of g square minus c, and on y-axis it is 2 times under root of f square minus c. I'll put them as very important, as in JEE means these things are very much asked all the time. So what does the intercept mean? So let us draw the graph of the equation of a general circle. This is x-axis, this is y-axis, and let this be a circle. So now the x-intercept, let me take another color for you to understand that. So the y-intercept has two of them on the y-axis. This is the y-intercept, or this is the y-intercept, and on the x-axis this is the x-intercept, and this is also the x-intercept. That's why there's a root which on squaring there's a f square minus c and a root, so there would be two values. If you square the left side of the coordinate, you see intercept would be the distance, and this distance would be given by some root formula, which we would equal to this thing of f square minus c, and on squaring both the sides the root would go, and this f square minus c, f square. So there would be two values which we can see graphically now. So I hope this is clear. I'll write it down, x-intercept, and I'll change color. For y-intercept I'll take a green. Green is basic. This is y-intercept. Okay, so now let us move further. Let us discuss a bit about concentric circles. What are concentric circles? This is the first question. So again, let us go to the graphs and understand graphically what concentric circles mean. So this is x-axis, this is y-axis, and this is the origin. So let this be the first circle, and let this be another circle. Now let me arrange it a bit quite like the one that is there. Yes. So these both these circles have different radii. Let this be the centers of both the circles. Let this be the centers which is just beside the origin, or let us shift them to the origin for better understanding. Okay, now we can assume that the origin is the center. Yes, and now origin is the center, and the first circle has radius r1 while the second one has radius r2. The circles which have same center but different radii are concentric circles. So we can see this is S1 and this is S2. This is just a denotation. So S1 can be equated to x square plus y square plus 2gx plus 2fy plus c equal to. Now you may say that in this case the center is the origin, so this both the terms x square, y square and c would get eliminated and the equation would be x square plus y square equal to 0. But I am writing in for a general case, as in for any circle to be valid. So x square plus y plus 2gx plus 2fy plus c equal to 0, and the second as x square plus y square plus 2gx plus 2fy plus c dash equal to 0. So the difference is over here. You can see, I'll use another color, sorry. The difference is over here. The intercept is different. C denotes the intercept on the y-axis, and the intercept on the y-axis is obviously different. I'll highlight it with a different color. Okay, blue is not visible. I'll use red. This is C1 while this is C dash. Now this is C. I'll write C for it. This is C and that is C dash. So you could see graphically much more clearly that this C is different and the C dash is different, while the center is the same for both of them. So this is the only change and easy to remember theory for concentric circles. Let us move further in circle chapter and understand the parametric point. In geometry, parametric point is very important as we substitute another variable in place of x and y, and over here if we have p as x comma y, then we can substitute p as r cos theta comma r sin theta, where r is the radius, indicates the radius. So now the parametric points, I'll make a table. and here is the equation. So now first one is x square plus y square equals to r square. Here we will substitute r cos theta, r sin theta as x comma y, indicated like that. The second one is x minus h this square plus y minus k this square equals to r square. Here we will replace x comma y by h plus r cos theta comma k plus r sin theta. And the third one, which is the general equation, x square plus y square plus 2gx plus 2fy plus c equal to 0. Over here we will replace minus g plus a cos theta comma minus f plus r sin theta. This is just a theory that we have to learn, and there is no other option to it. I'll put it in a tabular form for better understanding. Sorry, where did the things go? So now let us move further and understand the position of a point with respect to a circle. So I forgot to just position of a point x1 comma y1 with respect to a circle. So now there would be three cases. A, point is outside the circle. B, point is on the circle. And C, point is in the circle. So now just a minute, let me get these things a bit down, this also a bit down, and S indicates x square plus y square plus 2gx plus 2fy plus c equal to 0. Oh, we can't see now equal to 0, we know. And yeah, we can see it equal to 0, and this is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c, and now we can't see that as equal to 0. So if the point is outside the circle, the diagram might look like this. This is the circle, this is the circle, and this is the point, and this is the point P, that is x comma y, and this is S. So in this case S1 must be greater than 0. So this is a theory which we have to know. If point is on the circle, then it is obvious it would satisfy the equation of the circle, and this is the point P, x comma y, 1 x1 y1, and so S1 would be equal to 0. And if the point is in the circle, then S1 must be less than 0, and the diagram might look like this. This is the circle, and this is the point P, x1 comma y1. So now that we have sorted this theory out, let us now understand maximum distance of a point with respect to a circle. So now there are no cases over here. So let us draw this circle, and we are assuming that the point is outside the circle, because with inside the circle, if the point is inside here somewhere, then its maximum distance would be this, which can be there, which won't be asked sometimes. So we are assuming the point to be somewhere over here. This is point P, x1 comma y1, and now the maximum distance is this distance is the maximum distance. This whole length I will write, let this length be L1. This is the maximum distance, L1 max, and this is L2 minimum. So, and this is the minimum distance. So how can we write this distance in terms of radius? So we can write it as, let this point is, this point is our center, so we can write the maximum distance as, this will be R and this would be CP. So with respect to the circle, the maximum distance would be written as distance of C comma P plus R. This is a ready formula now. We can find the distance CP by using the distance formula between 2 points, and the minimum distance point and circle, which is over here L2 minimum, can be found out by, again we can see this is the whole radius R, and if we do CP minus R, we can get this L2 minimum. So we put a mod over there because distance cannot be negative, so all those subtractions sometimes might cause into error. So mod of distance of C comma P minus R. This is the formula for minimum distance. So now that we have discussed this, let us now discuss mandatory theorems. Some of the mandatory theorems are: number 1, perpendicular distance from center to line is equal to the radius, then that line is tangent. Let us understand this diagrammatically again. This is a circle and this is a tangent, and yes, this is the tangent, this is the center, this is the point P where they both meet, and this is distance R. So the distance of the center to the perpendicular distance from the center to the line, let this be T, tangent to the line, perpendicular distance from C to T is equal to radius, then T is tangent. This is what the theorem states, and we have to use it many times in this chapter in problem solving. Perpendicular, second one is perpendicular drawn from center to chord bisects the chord. And this is something we just have to remember because it is a proof not that much lengthy, and we have done this proof in lower standards. The third one is normal of circle passes through the diameter, passes through the center. And now some might be asking what a normal is. Normal is perpendicular line, and let us write it line perpendicular to tangent at a point, and it can be diagrammatically expressed like this. This is a circle. Let this be the tangent. So let this be the tangent T. Let this be the center C. And now the normal at this point is perpendicular of T, and I can represent it like this. It is a bit okay. Try to understand because the diagram is a little bit here and there. This is normal, and normal is perpendicular to tangent, and normal passes through center. So these three theorems are very important in this chapter, and you may need them here and there. So now let us move further and discuss about line and circle. So the first things first, this is the circle, and let this be the line. So here is our center C, and here is we draw perpendicular at the line, and let this point be P. So in such case, if it is a straight line outside the circle, then CP is greater than R in such cases. The R is the radius. The second one is, this is the circle and this is the tangent. So in such case, this is the center. We draw perpendicular. They are meeting over here. Let me draw the line a bit below. Okay, just a bit. And now this is point P. So this is R. So here distance of CP is equal to R. I'll write it distance of CP so that you may know that we have to find it by using the distance formula. This is over here. So here. And now the third one, wherein the line is inside the circle like this. So in such case, this is the center and this is the point P perpendicular, and this is the radius. So the distance of CP is less than R in such cases. Let me draw the line. It also got erased. So this is point C, this is point P. So yes, let us now understand about tangents and circles. Let us understand about tangents and circles. So the tangent equation with respect to x square plus y square equals to a square, and our general equation x square plus y square plus 2gx plus 2fy plus c equal to 0. So the first one is at point x1 comma y1. Here we will write x1 plus y1 equals to a square, and here we will write x1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equal to 0 at parametric point. here we will replace x1 comma y1. No, sorry, we would replace x comma y by r cos theta comma r sin theta. In this above equations only, we won't waste time in writing those again. Slope form, this is more important. The slope form is just this as the slope form in straight lines, mx plus minus a under root of m square plus 1. This is the formula over here in x square plus y square, and over here in this term we would write the equation with respect to line equal to y equals to mx plus c, and then the second thing would be to find c using property that the perpendicular distance, I'll just write the number because it's hectic. We'll use the first property over here of mandatory theorems, that the perpendicular distance between the center and the line, if it is equal to the radius, then that line is a tangent. Property 3, mandatory theorem. So this is the third, this is the second, this is, let us go on labeling them too simultaneously. At a point x1 comma y1 outside the circle. So over here we would prove the line as y minus y1 equals to m times x minus x1, and then we would find m by using mandatory theorem 1. Theorem 1. And we would do the same here, but in this equation. So that's just the change. So now that we have come this far, let us now understand the length of tangent from point x1 y1. There is a ready formula, and this also goes, I'll take it over on this side a bit, and in this only I'm continuing, and also in this I'm continuing. So the distance over here with respect to this form of x square plus y square equal to a square is x1 square plus y1 square minus a square is the length, and over here the length is equal to x1 square plus y1 square plus 2g x1 plus 2fy1 plus c, the whole goes in root. So this is the length of the tangent. And now further we will discuss about the normals and the circles. So now let us discuss about the normals and circles. We have discussed about the normals and what the definition of a normal is, and so now we won't be discussing it again. So let us understand how the equation of a normal looks with respect to the equation of x square plus y square equals to a square, and our general equation s equal to 0. So let us discuss first at point x1 comma y1. The equation goes as x by x1 equals to y by y1. Over here it is x plus g by x1 plus g equals to y plus f upon y1 plus f at the second at parametric point. Over here we would substitute x by x comma y by r cos theta and r sin theta in this above equations only. So won't be wasting time again, just substitute x and y by r cos theta and r sin theta and you will get the equations. So that's it for the number for the normals and the equations, let us go and understand about two circles. I got the spelling wrong. And so, for the two circles, number one, let the circles be orthogonal circles. So what does the term orthogonal circles means? So let me quickly draw the graph for explanation. So this is our axis and this is our x-axis, this is our y-axis, and this is a circle. Let it be a small circle because we'll be doing a bit of construction now. So in this circle, we'll be drawing two tangents. One tangent is this one and the another tangent being this one. Well, I'm taking small example because it may take time to construct tangents at every point. So now we have drawn these four tangents, and now orthogonal circle is a circle which is drawn by joining of two perpendicular tangents. So now this point, this point, this point and this point all lie on the circle which is orthogonal to this small circle. So that second circle I'll now draw by this color. So this circle starts from here, goes over here, comes here, joins over here. So let me adjust it a bit because we have that much of technology. A little bit big. It's not actually that much accurate, so the diagram may not be, but you got the idea on how this circle looks actually. Yes, one side, another side. It's that I'm pulling from one side. Okay, let it be. We won't waste time in drawing circles. You can see it out. And so for this, the first thing we do is we equate length of C1, C2, this square equals to R1 square plus R2 square. And then second thing, the equation of the circle looks as if S1 is equal to x square plus y square plus 2g1x plus 2 f1y plus c1, and s2 as x square plus y square plus 2 times g2x plus 2 times f2y plus c2. Then the equation looks like 2g1g2 plus 2 times f1 f2 is equal to c1 plus c2. So we need to remember this because they might mention that the circles are orthogonal, and then this theory should click in our mind. The second case is, now let us discuss about the circles by drawing the diagrams, and it's quite actually fun. And then another circle goes like this, and let us join these two and shrinken this a bit so that you may understand it. Okay, and now let us draw the common tangents. So the common tangent, first one would be this one. The first common tangent would be this one. Okay, I'll have to shift this. this would be the first common tangent. I'll name it as T1. Then the second common tangent would be this one, and the third common tangent would be this one. So let me arrange this tangents, this over here, this over here. Okay, let us name this as T2 and this is T3. So simultaneously we are covering the number of tangents and the distances between them. Let this be C1 and C2, the centers. So length of C1, C2, distance between C1 and C2 will be equal to R1 plus R2. So now let us draw where R1 plus R2 goes by another color so that it is understandable. This is R1 and this is R2. So it is the addition of those two. Now let us quickly draw the second one. That is, this is the first circle and the second circle is somewhat like this, touching the first circle. Okay, and let us name this as C case. Let this, okay, I need to reduce this up a bit. So this be the center of the first circle, this be the center of the second circle, and so the number of common tangents would only be one, and that common tangent would be this, if you could see it. I'll draw it with green. This is the common tangent. Let me just rearrange it a bit. This is the common tangent, and let me name it as T1 for them. And now let's see the distance between them. So the distance between C1, C2 is equal to R1 minus R2. And how did we get this? So let C1 be the distance of the center 1 and C2 be the distance of second center, and I mean radius of the second circle, and this will be the radius of the first circle. So if you subtract these, we get this distance, which is the distance that we want. So this is the easy one. And now let us see another case which not most of you might have thought might exist. So this is the first circle and this is another circle, and in this case the number of common tangents are only two, which is this and this, and I might need to rearrange it because it's not all looking common tangent, and this one as and let this be T1 and let this be T2, just for namesake I'm naming them. And let this be center 1 of circle 1, let this be center 2 of circle 2. And now let us see the radius. This is R1 and this is R2. So in such case, length of C1 C2 is less than mod of R1 plus R2, which it won't be negative but still, and R1 minus R2. I have to put a mod here, as you see. Let me now pause this because all of it is important. The next one. And the last one too. So now all these cases are very important and you need to keep them in mind. So now let us understand what a director's circle is, so the director's circle is the orthogonal circle. So in case of circle, now we'll see the equation of the director's circle. And yes, the circle here be x square plus y square equal to a square. So director's circle would be x square plus y square equals to 2a square. This is the one. X minus h the whole square plus y minus k the whole square equals to a square. Then here it would be x minus h the square plus y minus k the square equals to 2a square. Now that we have covered this too, yes, let us move further. And the last topic of our today is power of a point. Now, what is the power of a point? I won't be making any nasty jokes on what a power of a point is, but there's a simple formula, that is x square plus y square minus e square. And what is this? We have seen it somewhere like this, just that root has gone over. If you see, this is the square of distance, square of length of tangent, not distance. I was writing it wrong. This is the square of length of tangent from x1 y1. Yes, and a small little concept that is there is the slope of tangents. I promise this is the last one of tangent of circle x square plus y square equal to a square from point x1 y1. So now this is the circle, extremely sorry, this is the circle, and let this be a point. And now let me arrange this tangents well. Okay. Now these are the tangents that are at a point, and this is the point P, x1 y1. So now there would be two tangents and both would have a different slope. Let this be m1 and let this be m2. Then m1 plus m2 is equal to 2 times x1 y1 upon x1 square minus e square, and m1 into m2 is equal to y1 square minus e square upon x1 square minus e square. This isn't needed everywhere. This is only for a particular type of nuance of subtlety that the questions are asked in exam. This type of questions are of higher level, and just by seeing this you might have understand. And that is it. We have covered the complete chapter. Yes, now it's correct. And that's for today. And please drop the doubts in the comment section and we will answer you. Thank you.